Okay guys, it is time to hit the books and do a little review for Earth formation. Your quiz is going to look at how the Earth formed, evidence of this formation, and the composition of the Earth as far as we know it. And Bella says, you got this. Remember, the Earth formed 4.6 billion years ago. We're basically leftover stardust from when the sun formed. All of that electrostatic force and then gravitational pull brought pieces and parts together to make our Earth. And as those particles were hitting each other, there was an intense amount of heat and pressure. Like other objects in the universe, when particles pull together and rotate and clump into a planet or a moon or a star, there's a process called differentiation that happens. And as those really dense particles sink to the center, the less dense particles rise up past those, and this creates different layers within the structure. They're chemically different and they're physically different. Remember, this is all the pull of gravity and then density of objects moving around. That gave us the layers that we have today. So remember, the inner core is that solid part of the Earth, and it's about 3/4 the size of the moon. It's composed of iron and nickel, and it's super cool because it actually spins faster than the rest of the planet. It's also as hot as the surface of the sun, so an intense amount of heat and pressure in that area. The outer core is pretty cool too because it's also made of iron and nickel, but throw in some uranium and thorium, and actually those unstable elements are radioactive decaying, and so there's a little heat built up because of that as well. The motion between the inner and the outer core actually helps to generate electrical currents, and then these electrical currents generate Earth's magnetic field. So this magnetic field, remember, is super important because it protects us from a lot of the cosmic energy. And it reverses every 200 to 300,000 years. Scientists are still trying to work on that question, on why that happens. The superheated core. Remember, there's 3 big reasons why the core of the planet is so hot. There is leftover heat from when the Earth formed. There's also that radioactive decay from the materials that are breaking apart, like the uranium and thorium. We also just have frictional heating because as the materials move up and down throughout the Earth, that materials move against each other and they develop some frictional heat. As you move out into that slow circulating mantle, remember, there's a lot of different materials that make up this space. Iron, magnesium, silicon, and there's a couple of layers here that are more like putty, and then there are other places of the mantle that are like a little bit more cooled and they have a little bit more rigid type of, it behaves more like the crust. So don't forget to take a look at the asthenosphere and the lithosphere in your diagrams. Finally, the crust. That's where we live. So the crust is made up of like a lot of different elements, and we mentioned silica, aluminum, oxygen, but depending on where you're at, you're going to have different types of elements in heavier and lighter concentrations. This part of the crust is only, it's between 3 miles and 44 miles thick. It depends on where you're at. The oceanic crust is thinner than the continental crust, but all of this crust is really broken up into really big pieces called tectonic plates, and they're being pushed around the surface of the Earth pretty slowly. They don't move more than like 3 to 5 centimeters a year, but when they do move, we are well aware of it because we have earthquakes and volcanoes that get developed. In your research, you probably found other planets in the solar system that are a lot like Earth, especially those inner planets. The rocky planets like Mercury, Venus, Earth, Mars, we all have very, very similar ingredients and we all have very similar layers. We pull together from a lot of the same materials right around the closer region to the sun. So there are some of those outer planets, and these planets have a little bit different composition. We notice that instead of being completely like rocky, metallic, they have layers of gases and liquids in like hydrogen and helium that we don't have as heavy of a concentration of. So remembering that all of these planets went through that process of planetary differentiation, that's what keeps us in common, is that all those materials sorted by the density of the elements. You might be wondering, how do we know all of this? Well, we've been working on this question for a really, really long time, and we've been looking for evidence from all over. We have some evidence just based from like back when Newton was working on it. He looked at things like the density of Earth and the gravitational pull of Earth and the magnetic field, and he used a lot of indirect evidence. We also look at other places around the solar system and around our galaxy to get ideas for like how things are forming. And remember, we have some pieces of like really, really old material still left on the planet. We haven't found a ton of it, but we do have some like from zircon from Australia that dates us back 4 billion years. And we keep looking for this evidence. We look at meteorites that come into our atmosphere and come to Earth. We look at moon rocks that we have brought back to our planet. And we're still working on it. We don't know everything. We do know that the layers of our planet are not perfectly uniform, like all the diagrams show perfect circles. They are distinct, like the mantle and is the mantle, the core is the core, but they have different chemical and physical properties, and they're not perfectly sized all around. Remember, the crust is like only 3 miles deep in some areas and then like 44 miles deep in other areas. Now, to prepare for this quiz, go back through your notes. Look at the notes for Earth's formation. Look at the notes for Earth layer by layer. Look at the coloring page that you did and put in your notebook. And remember to go back to your Google Slides and study the last 10 words, reviewing them over and over again. Have someone give you the definition and you try to think of the word that matches. You can do this. Even Bella believes in you, although she's probably sleeping somewhere. All right, good luck.